Hello everyone, it's Benny, and in this video, we're going to keep working on our 2D RPG. Specifically, we're going to implement a better random number generator than just a wrapper for Java's random number generator. Why? Well, Java's random number generator, one, it's really old, and it's really not that good of an algorithm. It may surprise you to learn that random number generation is a really deep field. There's a lot that goes into it. And you can read all about that on the internet. There's a lot of information out there about it. I'm not going to discuss that in this video. But Java's random number generator is bad. It's somewhat slow. It has a very short period before it starts repeating itself. And yeah, if we're going to be doing an RPG which heavily relies on random numbers, you're probably going to want to implement a better algorithm yourself. Now, that being said, no one random number generation algorithm suits all needs. There's ones that are faster, there's ones that are more well-distributed, they give more, I guess, quote-unquote, more random numbers. There's ones that take longer times before they repeat themselves. Like, did I already say that? Whatever, you get the idea. There's a lot of different algorithms out there, and they all suit different purposes. The one I have picked out, it's not the fastest algorithm. It's definitely not the longest. Doesn't have the longest period, but it does have an extremely long period, and it is extremely fast. It's still not the fastest, still not the best, but yeah, it's a pretty good algorithm overall. And it's the WEL random number generation algorithm, specifically the WEL 512 implementation. And I'm going to be implementing a particularly optimized one, so it's going to be incredibly fast. Again, not the fastest. It's not going to outperform a highly optimized Mercine Twister. It's going to outperform most implementations of the Mercine Twister, but it's not going to outperform all of them. And yeah, so let's stop talking about it. Let's implement it. So this is the algorithm right here. This particular code isn't in Java. It's in C. As you can see, highly optimized, looks incredibly cryptic, not friendly, and as such, I'm not going to be explaining this algorithm because that's just going to confuse the hell out of everyone, including myself. So, if you want to learn more about this, I recommend Google, because I don't see me explaining this really working out that well for anyone. So yeah, let's go ahead and just implement this. So first off, I'm going to implement the actual generation of a random number. So I'm going to make that private. So private void get random. And private long. So, as you can see, this relies on 4 variables. They call it A, B, C, and D. Not the best variable names, but hey, I'm not complaining. Just going to copy and paste. And yeah, so while I just sort of write this out, can I sort of just get this? I can't get this to show up while I'm typing, can I? Oh well. While I just copy and paste one by one, let's talk about this versus the Mercine Twister, because that's sort of the other really popular random number generator, especially for games. It's extremely popular in gaming. Mercine Twister has a much longer period than WEL 512. Granted, WEL 512 still takes, at current computational speeds, over a Google years before it starts, a percent of random number generation, before it starts repeating itself. So far more than you'll ever really need to worry about. But Mercine Twister's longer, if you care. If you're talking about planning to generate numbers for over a Google years without reseeding the generator. And yeah, I'm just going to copy this and leave it up for you to copy yourself while I discuss it. How about that? And yeah, it's a linear concurrence algorithm, if you care. I don't, but hey, I mean, yeah. That's the style of algorithm. It's a particularly popular style of algorithm. They're both that style of algorithm. And the thing about the Mercine Twister, though, is although it's faster, it's not as well distributed, so WEL's a little bit better there. But the really bad thing about the Mercine Twister is it has a slight flaw, where if you seed the generator, I'm assuming you know what seeding the generator is. If you seed the generator with a number that has a lot of zeros in like the binary representation, it becomes really heavily biased. So if you get a bad seed, in fact, there's even this thing among RPG players which where they'll reset the console because they get a bad seed. If you're a hardcore RPG fan, you might have done this yourself. This is why. If you get a bad seed, which has a bunch of binary zeros, you're going to get a lot of numbers which are heavily biased for an extremely long time. How long is extremely long? It can take as much as 700,000 random number generations before the Mersenne twister becomes efficient again at generating good, well-distributed random numbers. So, yeah, that's one of the big weaknesses of the Mersenne twister, and if players, even if they are somewhat hardcore players, are actually doing things to avoid this downfall, I personally think that's enough reason to say, hey, let's not use it. And besides, well, 512, it's done by the same person, well, one of the two people who made it, and it's more modern. It is, again, slightly slower, but it's not going to be noticeable. It's literally on the order of nanoseconds slower. And this optimized version's faster than most implementations of that anyway, so yeah. Anyways, hopefully you get all this code. I'm not going to explain this, because yeah, you see why. There's unoptimized versions which are much easier to understand, although they're sort of relative in terms of random number generators, but yeah. So yeah, this is going to be our random state. Now, with all that out of the way, all the discussion of random number generators. Oh yeah, I almost forgot. As for the zeroing problem in, well, 512, that's the version I'm implementing. It has recurrence period of 2 to the 512 power. It still has a problem. The problem is with the style of algorithms and not the particular algorithm. Mersenne twister just sort of doesn't handle that weakness of the algorithm very well. Well, on the other hand, does. In this particular implementation, it takes less than 100 generated numbers before it gets back to well-distributed numbers again. Again, not perfect. It's a flaw of the algorithmic style, not the algorithm. But it's a hell of a lot better than 700,000 iterations. So, yeah. Anyways, back to the point of building this random number generator. This thing relies on states, as you see right here. I'm just going to copy from here because I'm lazy. So, yeah. And again, I'm sticking with the theme of not explaining, so private long, state, 16, and index. So, private index. That should fix most of the problems. Only line left here is this. Why are you causing me problems? Does this not accept hexadecimal? Is that the issue? Oh, it's because I'm casting it to an unsigned long, which doesn't exist in Java because, oh no, they decided you don't want unsigned numbers, so we just have signed numbers. Not that it particularly matters in this case, but hey, why not? So yeah, now these are giving me errors. Bracket thingamajiggy expected. Alt-enter, okay. What's the problem? No fixable error. Ah, I see the error. Well, one error maybe. That fixes that. State. Do I have to make a long array state? Okay, this is interesting. Does that work? Okay, I guess. And I'll just create a static initializer for the class, because someone was kind enough to point that out in the comments, which thank you very much, because I did not know you could do this. But yeah, this will happen whenever the, it's loaded. So, state is new long array size 16. There we go. And index, I guess I can initialize this to 0 here. Index equals 0. Slightly better. And, oh, private static. Almost forgot. Everything in here needs to be static because static class. There we go. Now, the algorithm's pretty much implemented right now. And, yeah. So, this is sort of going to involve a little bit of low-level stuff, so if you're afraid of working with real binary digits, you may want to just sort of go with it. I'll put it that way. But yeah. So, but not right now. Yeah, just yet. Only when we get to floating points, which will be slightly after this. First off, I'm going to go ahead and get rid of this, because, yeah. I can also get rid of this, I believe. I'm going to create a seed for the generator pretty soon, but oh well. So return ran.nextInt. That's Okay. Instead of returning next int, I'm going to return... Actually, one moment, I just got an idea. Actually, we are not going to have to deal with a bunch of really low-level bit manipulation, because the idea I just came up with appears to work. So yeah, for all people who hate that, you just got lucky this time. But yeah, here's the idea. Every single method in Java's default random class all depends on the next method. So here's my idea. I'm going to extend random from Control-Shift-I, java.util.random. And instead of creating a new method here, I'm going to override Java's next method and just get rid of all these. Because that way, what I can do is since every single method in Java's random depends on it, this will effectively do all that low-level bit manipulation for us, because Java already does that anyways. So I'm going to override, and it's going to be protected. Is it long? Protected long next. And I'll just see if this is what it is. If not, I have a tab open that lists it all out, because I just prepared just in case I forgot. Is that correct? It appears not. Google Chrome, save me. Protected int next. Int. Ah, okay. Well, it's asking for a certain number of bits, so I guess I'll just cast this to an int. It's technically not the best solution to this, but hey, it should work. And stat scale and stuff. Oh well. Anyways, static. I can get rid of all this now. This will all be instance-based. Instance-based. Can't talk today. That's alright. So, now I'm going to create public RPG random. And int seed. It's going to take in some seed. Why not? I should also create a constructor for if it doesn't take in a seed. And that'll just generate some seed, I suppose. I don't know. Why not? So, if I'm given a certain seed, I'm going to initialize all the states to something. So, for I is less than 16, I++. And in case you didn't look up the algorithm research on your own, the reason this works is because, as you see, well 512, all the random number generation is dependent on the states. So, in fact, all I'm going to do to seed it is set all the states to something. So, what should I do? Really, the method of seeding isn't particularly important, so I can effectively just say state sub I equals seed if I really want to. Although my only issue with this is if I pass in something like 0, that's gonna just create that big zeroing problem. So instead what I'm going to do is I'm going to take this, I'm going to do a little bit of math when I'm initializing. I'm going to say equals seed shifted left by 31 times I. And that's not going to work either, is it? Because that's not doing a rotary shift. Okay, I'm thinking of assembly. Don't worry about it. Alright, sorry about that. That's not going to work. But what I can do is I can say seed times I. I don't know. But I don't know, this still doesn't fix it if they make it 0. So seed times seed plus 1 times I. How about times seed plus 1 shifted over by 2? So that still doesn't fix it if it's 0. Okay. C plus 1. There we go. And this will effectively set everything to a different state, I suppose. I'm just thinking about something. How much have you left by I? Should I do that? That's a question. You know, it's just supposed to make it so it doesn't, I don't get a bunch of zeros. Oh, it still doesn't fix if they seed it with -1. Okay, how about this? Seed. That doesn't work either. Yeah. I'm just trying to make it so they don't set it to initialize to 0 by accident, because I know seeds like 0 and 1 are going to be pretty common. Those get tons and tons of zeros. So, how about that's gonna limit things, isn't it? No, it won't, because the whole purpose of okay, this is gonna limit the range that you can seed it in, but I don't care at this point. So seed equals math.abs seed. So just take the absolute value. That's my solutions to not making it negative. There we go. And does that work by default? I don't know. Let's find out. Enter. Okay, I could have sworn you needed to import something to use math, but hey, I mean, if it works. So yeah, this should seed the generator, hopefully. In theory, it should seed in a way that doesn't generate a whole bunch of zeros, at least unintentionally by the user. Ideally, you shouldn't go behind and correct the user like this, but I'm writing in Java, so yeah. I'm going to make sure they don't screw the generator up, hopefully. So again, seeds only used for testing purposes. Oh, don't worry about it. I got to implement it anyways, so why not? So, as for if I just get it normally, first off, I'm going to set state equal to... This is repeating code, isn't it? Long 16. I should just initialize it with some seed, if they give me some default generator. So what should I initialize it with? That's a question. So, I'm going to say this, sub 10. Is that how you... Does that work in Java? Okay, I'm not thinking of the implementation. Good. I'm not going to initialize it to 10, though. I'm going to initialize it to something better. Something more awesome, I guess. Well, maybe not, but... I'm going to cheat a little. I'll put it that way. I'm going to say random rand equals new random. Yeah, you see where this is going. And I'm just going to get some random number from Java's random pool. And I'm going to seed it with that. Call to this must be first. Oh. Oh dear. Okay. Here's what I'm going to do. I'm going to create a private method. It's going to be called seed. It's going to take in some seed. And for some reason that happened, but oh well. Not going to worry about it. I'm just going to take all of this code and put it in here. I'm going to say seed generator with the seed. There we go. And there. So I'm going to call this. That way it initializes everything. And, oh dear. That's not going to work either. Okay. Here's what I'm going to do. I'm going to move all this code up here. I'm going to call the this constructor from here. And but then it's going to okay, you know what? Screw it. I'll just copy and paste. It's just too much effort to avoid rewriting some code. So there. And I'm going to seed the generator with the seed. There. There we go. Private. Oh dear. Private void seed. There we go. There we go. That took... Oh, come on. What's the error now? Alright. ran.nextInt. Finally. All of this hopefully is cleared up now. That took way too long. But yeah. So next thing I'm going to do is I'm going to replace all these instances of using RPG random with the new implementation of random. So, instead of using RPG random.nextDouble, I'm going to implement my new instant-based random. And that's sort of the beauty of doing it like I did. Because, oh yeah, don't need to initialize anymore. That's all fine. Does that fix all those errors? Good. Now here, I believe this is the only place I'm using it so far, am I correct? Excellent. So I'm just going to have a private RPG random, rand equals new RPG random. Just gonna get some, yeah, something. Just gonna get the default seed, or some random seed, not going to specify one. Rand.next double. Rand cannot be applied to the given types. Required, no arguments. Oh, right, because I implemented this a little bit differently, didn't I? Well, I want values between 0 and 1, so this, I believe this by default gives us that. So, yeah. Because I'm pretty sure I just had a huge issue with that in the last video, but I'm going to double check on the documentation just to be sure. So, one moment. Alright, so I went ahead on the Java documentation, double checked. But wow. Double checked, see what? Didn't even intend to do that. Oh man. I just, no. Anyways, let's just pretend that didn't happen. But I did check on the documentation, and yeah, I was correct. It does generate between 0 and 1. So yeah, that pretty much completes our new random system. And unfortunately, I'm about the 20-minute mark. The next thing I want to do in the video series, well, yeah, I guess in the game, is to start implementing levels. Not like levels like leveling up, but implementing levels like I can create this giant level of mountains and whatnot, and then I can save that somewhere, so I can do IO. I can start actually saying this level has these objects and they're in this position and stuff. And yeah, that's sort of, or at least that's the next big direction I see us going in, even if that's not like the next thing I do in the next video, but that's sort of the direction I want to start heading in. And unfortunately, I can't really think of anything that sort of gets that started, which won't take a full video length of time. I don't see me getting, like, if I start something new now, I'll be like 20 minutes in, and they'll be like, okay, I gotta stop this right in the middle, and I don't see it working out. So I'm just gonna go ahead and call the video here. I know it's a bit shorter, but oh well. In the next video, we're gonna start moving in that direction. I'll put it that way. I haven't fully decided which part I'm going to implement first, but hey, we'll see next week. Thank you, and I'll see you next time. Take care, and enjoy your new, super fancy random number generator. Feel free to do some more research, do some stuff, and yeah, see you next time.